Hello everyone, welcome to this lecture. In this section, we are going to talk about inheritance. So inheritance in C++ is a key concept in object-oriented programming. It allows one class, we call it derived class, to get the properties and behaviors of another class that we call a base class. And it helps to reduce duplication. Why? Because code from the base class can be reused in the derived classes. So new classes can be created with additional features without modifying the base class. So inheritance mirrors a real world relationship. For example, we can have a dog that is a mammal. So think of a vehicle manufacturing company. They make general vehicles, but then they want to make cars and bikes. So instead of designing everything for each type of vehicle, they can define common properties, for example, vehicles or engine, and behaviors like the start and stop in a general vehicle class. So think of inheritance this way. So let me give you an example. So here I provided an example in C++. I'm having one base class here and one derived class here, and then I'm having my main function here, okay? So in the base class, the name is vehicle, and in the public part, I'm having two void functions. One of them is start and the other one is stop. So when the start function is called, we are having the message in the terminal vehicle started, and when the stop function is called, we are having the message in the terminal saying that vehicle stopped. And then I'm having a class derived from the vehicle class. To have a class derived from vehicle class, I'm having the class keyword and the name of the derived class, colon, public vehicles. This means that it is going to have access to the public part of the class vehicle, and the public part of the class is here. Okay, and in the public part of the class car, I'm having a function called honk. So, and we are showing this message in the terminal when this function honk is called. Okay, and in the main function, I'm creating an object called my car from the derived class, which is car. Okay, so I'm creating an object. The object that I'm creating, the name is my car, and this object is created from the car class, and the car class is derived from the vehicle class. Okay, then because this car class is derived from vehicle class using the object of the car class, I should be able to access the functions in the vehicle class. To do that, I'm having the object of the car class, which is my car, dot start, which is the name of the function in the vehicle class. Okay, so it can be accessible because this car class is derived from the vehicle class, or we can say inherited from vehicle. Okay, then I'm having my car object dot this function honk, which is the function of the car class, so there is no problem, we should be able to access it as well. And then I'm having the my car object dot stop, which is the function of the vehicle class. So it is also inherited from the vehicle class, therefore it is accessible. So let me run the code. So when I run the code, I'm calling first the function start. So the function start vehicle started, the message is shown here. Then the honk function is called here. So this message is shown in the terminal car horn beep. And then I'm calling the stop function, and the stop function is showing the message vehicle stopped, and vehicle stopped is shown in the terminal. Therefore, in this video, we learned how to have a class derived from another class and how to create an object from the derived class to call the functions in the base class. This is what inheritance is all about. In the next videos, we are going to discuss about different types of inheritance. There are three types of inheritance that we are going to discuss: single, multiple, and multi-level. In the next videos, we are going to discuss these details and then provide some coding exercises to understand base and derived classes, or the inheritance topic in general, better. Thank you for watching. Hello everyone, welcome to this lecture. As we discussed in previous video, there are three types of inheritance in C++: single, multiple, and multi-level. In this video, we are going to talk about single inheritance. So in single inheritance, a class derives from one base class. For example, a dog inherits properties from animal. So we are having our base class declared here. The class name is animal, which is our base class, and it has one function called eat. And when this function is called, the message "this animal eats food" is shown in the terminal. And we are having a derived class from this animal class. We are having the keyword class, then the name of the class, then colon, then public animal, meaning that this dog class is derived from the class animal. And in the public part, we are having the function bark. And when this bark function is called, we are having this message shown in the terminal. So this is how a single inheritance is implemented in C++. A derived class is being inherited from one base class. So this is our base class and this is our inherited or derived class, okay? So what we are having here is the following. We are creating an object called myDog from the dog class, which is our derived class, and using this object, I'm accessing this function in the class animal, okay, in the base class, which is inherited from animal class. And then using the same object, I'm accessing and calling this function bark. So when I run the code, I should be able to see this message first and then this message. Let me run. So when I run, we see that both messages are shown in the terminal. Basically, the concept of single inheritance in summary means that we are having one derived class, and this one derived class is being inherited and being derived from one and single base class only. That's what a single inheritance means. In the following videos, we're going to talk about multiple and multi-level inheritance in C++. Thank you for watching. Hello everyone, welcome back. In this video, we're going to discuss multi-level inheritance. So in multi-level inheritance, a class is derived from a derived class. So let me illustrate it with an example. We are having one base class that is called animal. It is having one function that is called eat. I'm having a derived class that is inheriting from the animal class. So this class called dog is a derived class from the animal class, okay? And then I'm having a class called puppy that is derived from the dog class. So let me review it one more time. So I'm having one base class called animal. I'm having a derived class from this animal class, and I'm having a puppy class that is derived from this dog class. So this is a multi-level inheritance in C++. So now I'm creating an object called myPuppy from the puppy class that is derived from the dog class, and the dog class itself is derived from the animal class. Okay? So using this object, I can directly access the animal class. It's interesting, no? Because puppy is not directly derived from animal class, but it is derived from the dog class, which is itself derived from animal class. However, using an object from the puppy class, I can directly access the function it from the animal class, and also the bark function from the dog class, and the whip function from the puppy class itself. So when I run the code, I should be able to see this message first: this animal eats food. Then this message: dog barks, woof. And then this message: puppy weeps, whisper. Let me run the code. So when I run the code, I see there is no errors. So animal eats food, then this message, and then this message is printed out in the terminal. So using a multi-level inheritance in C++, this puppy class is indirectly derived from the animal class, because puppy is derived from dog and dog is derived from animal. However, an object of this class can directly access the functions in the base class as well. Thank you for watching. Hello everyone, welcome to another lecture. In today's video, we are going to talk about multiple inheritance. It means that a class can inherit from more than one base class. In order to have a coding exercise here, we are going to implement this concept in C++. So I'm having base class 1 here. The name of the base class 1 is a student, and we are having one function called study. And when this function is called, this student studies is going to be printed out in the terminal. Then I'm having my base class 2 here, and the class name is athlete, and it has only one function called train. And this function, when it is called, it is showing the message to the user in the terminal saying that this athlete trains. Now this is the base class 2. So we are talking about now the derived class. So in order to type down a derived class, we are having the keyword class and then the name of the class, which is here student athlete. And this student athlete class is a derived class from student and athlete. So you see that we are having colon, then public keyword and the name of the first base class, and the public keyword and the name of the second base class here. And in the public part of the class student athlete, I'm having one function called play game. So this student athlete plays games. So this is the message that is shown in the terminal when the play game function is called. So let's move on to the int main function. In the int main function, I'm creating an object from this derived class, and the object name is SA. So using this SA object, I should be able to access both base classes. So using this object, I'm calling the study function that is in the first base class, in the student class, and then I'm calling the train function, which is in the base class number 2 in the athlete class. And then also using the same object, I'm calling the play game function, which is in the function that is called student athlete. So there is no problem because this object is created from this class. So we see that we can have multiple inheritance type in C++. So one class, one derived class can inherit from many classes, more than one classes. So when I run the code, we see that there is no error. So this student studies is the message from the study class that is called here. Then this athlete trains is from the athlete class, the base class number 2. And then this message which is for the student athlete class, and this object is of that class, so there is no problem to access that as well. We see that this is how an implementation of multiple inheritance type in C++ is like this coding exercise that we showed here. Thank you for watching. Hello everyone, welcome to this lecture. In the previous video, we saw that it's not possible to access the private function of the base class, and we said that the solution is to have a friend class. Okay, in this video, we are going to create a friend class and show how it is possible to access it. So if you want to know about friend classes, we have this being taught in our upper intermediate level. So I refer you to videos of that course. However, here I'm going to just give you an example of how a friend class, helping us to have access to the private part of the base class. So in the base class parent, I'm having a friend class called my friend class, and then I'm declaring my friend class. So I'm having the class keyword, my friend class, and it is derived from the parent base class. So it is also a friend class and also a derived class from the parent base class. Okay. And in the public part, I'm having a function called access private. So when I call this function access private, it is going to call the show private function, which lies in the private part of the base class parent. Okay, so it is possible to access this show private function here exceptionally because it is a friend class derived from the base class. Okay, we use this friend keyword here. So now in the int main function, I am creating one object called C from the my friend class, and using this object, I'm calling access private function. So this access private function that lies in my friend class, what basically it is going to do is the following. It is going to call the show private function, and show private function is in the private part of the base class parent. So when I run the code, this time we see that there is no error, and we can simply access the private function, the show private function in the private part of the class parent, and private method of parent not accessible is now printed out in the terminal. So we learned these lessons. First of all, when we are having a class derived from the base class, it can access directly the public public functions of the base class in the int main function. But in the int main function, it cannot access the protected functions. In order to access the protected function in the int main function, we need to call a function in the derived class, for example, the display function, and that function needs to call the protected functions in the protected part of the base class. And finally, for the private functions, it's not possible to access it using a derived class. There is no way. In order to access the private part of a base class, we need to have a friend class that is derived from the base class. And that friend class needs to have a function. That function needs to call the protected function in the protected part of the private function in the private part of the base class. These were the lessons and things that we needed to know about inheritance and friend functions, friend classes. Thank you for watching. Hello everyone, welcome back. Now we are going to write a program that accesses public and protected functions of a base class. So this is called access specifiers in inheritance. I'm having one class, one base class called parent, and this is the parent class. It has public, protected, and private part. So in the public part, I'm having this show public function. In the protected part, I'm having this show protected function. And in this private part, I'm having the show private function. Then I'm having a class called child that is derived from this parent class. Okay, and it has one main function. So in the function called display, it is going to have, when this function display is called, it is going to call show public and show protected functions of the parent class. Okay, so the job of this display function is to call show public and show protected functions of the base class. So now in the int main function, let me comment this part first. So I'm not going to call this display function. So first in the main function, I'm creating an object called C from the child function, from the child class, which is the derived class. And then I'm calling the show public function, which is of the public part of the class parent. So when I call this show public, let me run. So when I call this function show public, which is in the public part of the base class, this message is shown. So public method of parent. So this is how we can print out the public method of parent. Easily, we saw that using an object of the derived class, we can access the public part of the base class. But is it possible to access the protected class of the base class? Let's try. So when I have this code, that the object of the derived class C is going to call the function showProtected of the base class, we are seeing the error saying that showProtected is a protected member of the parent class. So it is not possible to access this function directly from the main function. How can we access this protected function then of the base class using an object of the derived class? So in order to do that, I comment this part, and instead I'm going to call the c.display function. So display function is a function in the derived class, in the class child, and this function is going to call the showPublic and showProtected function, both of them together, showPublic and showProtected. So the showPublic is in the public part of the base class and showProtected is in the protected part of the base class. So let me comment also this part because I don't want to separately call the showPublic part, which we did earlier. So I'm just going to call the display function. Display function is a function in the derived class, and it is going to call two other function itself. So these two functions are showPublic and showProtected. So when I run, so this time we have no errors. So we see that the public method of parent is printed out and protected method of parent is also printed out. So one lesson lies in this coding exercise. In order to access the public part of a base class, we can create an object of the derived class child and access directly through the int main function. However, for the protected part, it's not possible to directly do it in the int main function. We should call a function in our own derived class, and that function has to call the protected functions from the base class here. So I say it again. When I'm creating an object of the derived class child, I can directly access the public functions of the base class. However, I cannot directly access in the int main function access the protected functions of the base class using an object from the derived class. To do that, to have access to the protected functions of the base class using a derived class, we need to define a function in the derived class, and that function is going to call the protected function of the base class. This is how we can get access to the protected part of a base class. So this is one feature that we need to keep in mind when working with inheritance in C++. However, what about this function? So what about this private function? When we are having this show private function, so when I call this function show private here, we see that, of course, when protected is not possible to be accessed directly in the int main function. Of course, in the int main function, I cannot also access to the private function of the base class. So this is not accessible, and this is also not accessible here. So even if I want to access the private part of the base class in my derived class, I cannot do it. So I cannot call the private function of the base class even using a function in the derived class. But then what is the solution? How are we able to access this function? In order to access this function, you need to define a friend class. So when you define a friend class, that friend class can have access to this private part of the base class. So this is the solution of how we can get it solved. This is the only way to access the private function, the private part of a base class. A friend class is one solution to do it. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we would like to write a program that creates constructors and destructors in inheritance in C++. So I'm having one base class here called parent. It has a constructor and it shows the message parent constructor called, and it has a destructor parent destructor called. And we are having one derived class called child, and it has its own constructor and destructor, and it is going to show the constructor child constructor called when the constructor of the derived class is called, and then we're having the destructor. When it is called, it is showing the message child destructor called. Okay, and in the int main function we are having a message showing that creating child object. Then we are creating an object of the derived class, and when the creation is done, we are having this message showing that exiting main function. Okay, so let me run the code so we see how it works. Okay, so now we see that when we are having the int main function, first of all, this creating child object is printed out, which was a message that we typed down there. Then we created the child object. As soon as we create the child object, first of all, the parent constructor, and second of all, the child constructor is called. So this is how, when we are having an inheritance and derived class from a base class, things will work in C++ with respect to constructors and destructors. So as soon as we create an object of the derived class, both constructors are going to be called. So the parent constructor first is called and then the child constructor is called, even though we are creating an object of the derived class and not from the parent class. Okay? So when I'm having an object of the derived class, both constructors are called. Then whatever we are doing here, we can type down our code, whatever here, and then this message is printed out, exiting main, meaning that the program is ending. And after that, when we are reaching the end of the program, first the child destructor is called, and then the parent destructor is also called again. So it was very nice to show you in an example implemented in C++ how constructors and destructors would work in inheritance. And it was an interesting point to keep in mind, to know that even if you're creating an object of the derived class, the base class constructor and destructor are going to be called using an object created from the base, from the derived class. Thank you for watching. Hello everyone, welcome to another lecture. In today's lecture, we would like to write a program that addresses a multi-level inheritance and call functions with similar names in derived classes. To do that, I'm having one base class here called shape. So let me just comment base class here. And it has one function called display. I'm having the derived class one here. The derived class, let's say, not one. So we are having the class the class circle that is derived from the shape class. Okay. And then it has one function called area. So this is the derived class 1, and then I'm having derived class 2 here, and we're having a rectangle that is derived from shape as well. So we are having two derived class from one main base class, okay? And in the int main function, so basically this area function is shared between these two derived classes, but they are not related to each other in any way. They are only derived from the public shape base class, okay? So calculation of area of rectangle, and instead of this formula here, I would say calculation of area of a circle, for example, and of a rectangle here, okay? And in the int main function, I'm creating an object of the circle class, the first derived class, and I'm calling the display function. Display function is the function in the base class, okay? And then I'm calling the area function. The area function that I'm calling using the object of the circle class is going to call this area function and not this one. Why? Because it has nothing to do with this one. This derived class is derived from this class, and this derived class is also derived from this class. But these two derived classes are not having anything in common with each other. They're only having one function that is having a similar name. But apart from the function, they are having nothing to do with each other, okay? Therefore, when I'm creating an object from the circle class and I'm calling the area function using that object, it is going to call this function, okay? I just wanted to make an example and make sure that you're not confusing the concepts. And then I'm creating an object of the rectangle class called R. Using this object, of course, I can call this display function in the base class. And then I'm calling with this object, I'm calling the area function. And when I'm calling the area function, because the object is created from this rectangle class, it is going to call this area function and not this one, because it's an object of this derived class. Okay, so let me run the code. So when I run the code, it prints out I am a shape. So I am a shape is the message from the display function. So the display function is called here, I am a shape. And then we're having the area function called from the derived class 1. So area of circle, calculation of area of a cycle. So this area function is called, okay? And then here I'm calling the display function again. I'm a shape and I'm calling the area function, and the area function is being called from this class, and it is showing this message in the terminal. So this was a good example of how to create two objects of two different classes that are derived from one base class, and how it is important to make sure that if you're calling the area function, it depends with which object you're calling that function. Depending on that, it is going to call this function or this function because they are derived function from one base class, but these two derived function have nothing to do with each other. It's like we are having one function here, one base function here, and we are having two derived function. These two derived function are connected with this base class, but they are not connected like this horizontally. Okay? Thank you for watching. Hello everyone, welcome back. In today's video, we would like to talk about single inheritance. So we would like to write a program that demonstrates single inheritance where a car class inherits from a vehicle class. Here is my class called vehicle, and then in the public part, we are having a function called display. it's a void type, it's not going to return anything. Only it is going to show this message in the output whenever that it is called. This is a vehicle. Then I'm having another class called car, and it is inheriting from the vehicle class because we are having the colon here after the name of the car class. We're having the colon public vehicle. Okay, so it is inheriting from the vehicle class. In the public part, I'm having a function called car details, and this function, it is of a void type, so it's not going to return anything. And whenever that this function is called, it is going to show this message, this is a car. After that, in the int main function, we are creating an object called my car from the car class, okay? From the child class, let's say. So this main class or base class or parent class, and this one is the derived class, or we can say child class, okay? So this derived class car is used, and we are creating an object of this car class, okay? Using the object of the derived class, we can access the function in the base class, that is display. So display is called using the object of the derived class car. Then using the same object, I'm calling the car details function, which is a function of the same class car, okay? So I create an object of the derived class. Using that object, I am calling a function from the base class, and also I am calling a function from the derived class, okay? So when I run this code, here we see the message. This is a car, this is a vehicle, this is a car. So this message is shown and this message is shown. So we see that when we are having a derived class and we are creating an object from the derived class, we can access both the functions from the base class and also the current class, which is a derived class. Okay, thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about multi-level inheritance. We would like to show how a class can be derived from another derived class. Here is my class called animal. It has one function called eat, and whenever that this function eat is called, animals eat food message is shown. Then I'm having a class, a derived class called mammal. It is derived from the animal class, and it has one function called give birth. Whenever this give birth function is called, this message is shown in the output. Mammals give birth. Then this dog class is created, and it is derived from the mammal class. Okay, and this dog class is having one function called bark. Whenever this bark function is called, it is going to show this message in the output. Dog barks. And in the int main function, we are creating an object called myDog from the dog class, okay? Here. And dog class itself created from mammal class, it is not created, it inherits from the mammal class, and mammal class inherits from animal class, okay? And using this object from the dog class, we can access to the function in the animal class and the function in the mammal class, and of course the function in the dog class, because it was an object from the dog class. But because dog inherits from mammal and mammal inherits from animal, using the object of this dog class, we should be able to access all the functions. So I use the object to call the eat function, then to call the give birth function, and then to call the bark function. So when I run this code, I expect to see animals eat food message, mammals give birth, and dog barks. So when I run this code, we see that these three messages are shown in the output. So animals eat food, mammals give birth, and dog barks. This is how we can create an object from a derived class and access the functions of the base class. For example, here we had the myDog object, dog class was inheriting from mammal, and mammal was inheriting from animal. Although dog was not directly inheriting from animal, but it was possible to use the object of dog to access this function. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to illustrate how multiple classes can inherit from a common base class. So our base class is called shape. It has one function called display. Whenever this display function is called, this message is shown in the output. This is a shape. We are having a circle class inheriting from this shape, so it is derived from the shape class. It has one function called area. It accepts one argument, and then it is going to calculate the area of a circle using this formula. So the argument is radius, and radius multiplied by radius multiplied by 3.14 is going to be the area of the circle. So whenever this function is called with the corresponding radius, it is going to calculate the area of the circle for us. Then we are having another class called rectangle. It is also inheriting from the shape class, so it is also derived from the shape class. So these two classes are both derived from the shape class. And whenever the area function in the rectangle class is called, two arguments are passed, the length and width, and we are going to calculate the area of the rectangle using the length and width when the argument they are passed as arguments when calling this area function. So we are going to call the area function using two arguments. The first one is length, the second one is width, and we are going to use the length and width to calculate the area of this rectangle. Here we are creating an object of the circle class called myCircle, and we learned that using the object of the derived class, we should be able to access the functions in the base class. So I use the myCircle object to call the display function from the shape class. Then I use the same object to call the area function. So the area function that it is going to call is this area function and not this one. Why? Because we create an object from the circle class. So we create an object from the circle class, which is called myCircle. Therefore, when I'm going to call the area function, it is going to call this area function, and the radius is going to be the argument in parentheses. So we are passing 5 as the radius. So it is going to take the 5 whenever this area function is called. It is going to take the 5 and multiply it by another 5 and multiply the output by 3.14, and therefore it is going to return, it is going to show the area of the circle for us in the output. And then I'm creating an object from the rectangle class called myRectangle. And again, we can have access to the display function because rectangle class is derived from the shape class. So we are calling the display function. And then when we are calling the area class in the rectangle class, I'm passing two arguments. Why? Because it needs two arguments, length and width. So length is 4 and width is 6. And this way we are going to take the length and width and calculate the rectangle area. So when I run this code, here we see we call the display function. So display function, this is a shape message is shown. So this is a shape, okay? Then we are calling the area function with the radius 5. So this circle area is calculated to be 78.5. Then we are calling the display function again. So this is a shape message is shown. This is a shape message from the display function from the base class. Then we are calling the area function with 4 and 6 arguments, with the arguments that are 4 and 6. Length is 4, width is 6. And the rectangle area is length multiplied by width. So 4 multiplied by 6, the output is 24. So the 24 is shown here in the output. So this is how we can illustrate how multiple classes can inherit from a common base class and still can access to the function from the base class while they are having access to their own classes that are called area, for example, in our example here. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to discuss multiple inheritance. We would like to illustrate how a derived class can inherit from two base classes. Here I'm having a class called employee. It has one function called work, and whenever this work function is called, this message is shown in the output: employee works for a company. I'm having another class, another base class, let's say, called freelancer, and it has a function called freelance. And whenever this freelance function is called, freelancer works independently message is going to be shown in the output in the terminal. Then we are having a class called hybrid, and it is derived from both employee and freelancer class. Okay, it is derived from these two base classes. Then I'm creating an object called a worker from this hybrid class. Using this object called worker, I access the function in the employee class, I access the freelance function in the freelancer class, and I access, of course, the hybrid work function. And whenever this hybrid work function is called, this message is shown in the output. Hybrid worker does both. When I run this code, we see that there is no error, so it is possible for a class to inherit from two base classes. And we see that first we call the work function employee works for a company. So employee works for a company message is shown in the terminal, no problem. Then we call the freelance function. The freelance function is from the freelancer class, and it is showing this message: freelancer works independently. So this message is shown in the output. And then we are calling the hybrid work function, and it is going to show hybrid worker does both. So hybrid worker does both. Here we practiced a multiple inheritance. So one derived class can inherit at the same time from two base classes, and of course it can access, as we learned, to the functions of the base classes. Thank you for watching.